All right, folks, number 4 on the test that you're going to be doing tomorrow is very similar to this one. They give you a little bit of a word problem tomorrow, and they talk about two fences that are in a certain angle, and it's like at a park, and they want to actually, I think there are two streets that intersect at an angle, and then they want to fence in this area and have like a little park in here or something like that. So we want to know what the area of this sector is. All right, so I would start by drawing the sector, and then I want you to put this formula in your notes, okay? We're going to use this formula, and real quick, let me just explain where the formula comes from. If you want to know what fraction of the circle you're dealing with, like right now we're in degrees, right? I would go 160 degrees divided by 360 degrees, and that would tell me what fraction of the circle I'm dealing with. And then I can multiply that by the area of the whole circle, right? The area of the whole circle. And that would tell me the area of this sector, right? That's pretty straightforward. If I was in radians, though, think about this for a second. Instead of dividing by 360, I would take my angle and divide by 2 pi, because 2 pi is the same as 360, right? And we know the area formula for a circle is pi r squared. So if I took the area of the circle, the whole circle, and I multiplied it by the fraction that I'm dealing with, then the pi's divide out. We're left with a 2 in the denominator, and we have r squared theta divided by 2, right? Or 1/2 r squared theta. So it'd be nice if our angle was in radians, and we could spend a second converting it to radians and then use this formula. Or you could just use this formula right down here. We'll see which one you like better. So let's see. How do I convert to radians? I take 160 degrees and I multiply by something equivalent to 1. Like pi is the same as 180 degrees, right? Same angle. And so let's see, I could just reduce this a little bit, right? The zeros, you could divide both by 10, you could divide both by 2, we're down to 8 ninths, right? So we got 8 pi ninths. Okay, so the angle that I'm dealing with is 8 pi ninths. So now to use this formula, this theta has to be in radians. Make that note. That's why I just converted my angle to radians. And so I go, let's see, I go 1/2. My radius is, area. Oh, see, they're telling us the area. So I'm going to put 1,500 on this side. And I forgot about that. I'm looking for what the radius is, right? What's my radius need to be to cover an area of 1,500? So, and then my angle is 8 pi ninths, right? So if I multiply both sides by 2 and I multiply both sides by 9 over 8 pi, I'd have r squared all by itself, right? So I got 1,500 times 2 times 9 over 8 pi. And then, of course, I'm going to take the square root of all that stuff, right? So let's open up Desmos. Excuse me. There's Desmos right there. Let me jump back over here real quick and move my screen up so you can see the numbers that I'm just going to crank out here in a second. All right. So I'm going to type in square root first, and then I'm going to go 1,500, and then times 2 times 9 divided by 8 pi. And I get 32.77. What do they want me to round to? Shoot. What do they want me to round to? To the nearest tenth. Okay, so let's see. I want 32.8, right? So 32.8, let's see here. 32.8 is going to be my answer here. 32.8, was it feet? Yards. Okay, so yards. So you might be saying, well, why spend that time converting to radians? I don't know if I have a great argument for that. Would this still be possible doing it this way? Of course it would. You don't really have to reduce. You're on Desmos, right? So we can multiply by, and this is, by the way, pi r squared, right? So we're going to multiply by 360 over 160. So let's go back over here and let's see if we can get this to work out here. Let's see. I still want 1,500 in there, but right here, I would have 360 divided by 160. And then over here, I'm going to put down, let's see, we had pi r squared in there. So I'm dividing by pi, right? Okay. So I got to divide by pi. So right here, I'm just going to jump down in the denominator and put a pi right down there. Hey, look at that. I get the same answer, 32.8. So you don't have to convert to radians and use this formula, but it's pretty convenient if you do. All right, so let's try another one here. That was the first test that we got, first practice test. See, now this one, it's nice. They tell us in radians, 4 pi thirds. The one tomorrow is in degrees. Okay, so it's up to you whether you want to use the formula or not. Let's see, what was the formula again? It was 1/2 r squared theta is equal to the area of the sector. So let's see, what do I know? I know the radius is 3 inches, 4 pi thirds, central angle 4 pi thirds. Let's see, what does that look like? That's, oh my, that's like this, right? 4 pi thirds is more than 1 pi. So 4 pi thirds, okay. So that's the area of the sector that we're looking for. And I just take my numbers and I plug them in, right? So let's see, the area of a sector of a circle with radius 3 inches and a central angle. What's the radian measure of theta? And a central angle of theta is 4 pi. Yeah. I'm sorry. This is just like the other one. They told us 4 pi thirds is the area of the sector. I forgot about this one. And so we go 1/2. Let's see, the radius is 3. And they want to know this time the angle. And it does say in radian measure, right? So that's kind of what I was saying. So we got 9 over 2, right? So we got 9. Let's do a little work here. 9 over 2 is 4 pi thirds. And then let's multiply by 2/9. So if I multiply 4 pi thirds by 2/9, I get 8 pi over 27. 8 pi over 27. 8 pi over 27. All right. So that formula is pretty useful on this problem, isn't it? Right. Okay. Let's try another one. Number 4 says it's amusement park, pendulum, 170-degree arc. Okay, let's draw a 170-degree arc. Here's a 170-degree arc. And put 170 right there. If the radius is 40 feet, okay, how long is the path the ride takes? Ooh, now this one's not an area problem, isn't it? It's more of an arc length problem, right? So this one is kind of interesting. The arc length, if you're in radians, let's see, radians means the arc length, right? So if I had this in radians, that would be the arc length if we had a radius of 1, if we were in the unit circle. So we just need to take it times 40. So we're going to take 40 times whatever 170 is in radians. So if I go, I'll put it right in here, 170 times pi over 180. See, I'm converting it to radians. See, if I had this in radians, then I could just multiply it by the radius. And that's all you got to do, right? So jump over to Desmos, crank that out. Hey, so I'd be ready for an area problem tomorrow. I don't think it's going to be an arc length problem, but it has to do with radians, right? And degrees. They're going to give it to you in degrees, and you might want to convert to radians. So I hope that helps. I'm going to see you guys tomorrow, and we're going to do page 1 of the final. You can use all your notes. Miss Jarman said to her classes they could use their whole notebook if they wanted. So bring your notebook tomorrow, and good luck. Thanks for watching my video.